Hello to everyone. Let's talk about factor analysis. Please don't forget to subscribe and like. Factor analysis is a statistical method used to describe variability among a large number of observed correlated variables in a smaller set of factors. For example, variation in some observed variables reflect variation in one unobserved variable. The goal of factor analysis is to divide variables into groups of those that are most correlated. Within the groups, variables should be as highly correlated as possible, and between the group as low as possible. Here you have an example. We see variables connected to the factor. We have factor 1 and factor 2. As a part of a general linear model, there are key assumptions such as linear relationship between variables, absence of multicollinearity, relevance of the variables, the existence of true correlation between the factors and the variables, sufficient variables for each factor, adequate sample size, no outliers. We have factor analysis that extract a common variance among variables. We have image factoring based on the correlation matrix. It uses ordinary least squares regression to predict factors. We have maximum likelihood method based on a linear combination of variables, working from the correlation matrix to four factors. We have other methods like alpha factoring, unweighted least squares factoring, generalized least squares factoring. Key concepts in factor analysis, we have factor loadings, represent correlation between the variables and the factor. We have variance, measure the split of numerical values around the average. We have eigenvalue, represent variance explained by a factor out of the total variance. If a factor has an eigenvalue of 1 or above, means that the factor explains more variance than a single observed variable. Type of factor analysis. Confirmatory factor analysis, the researcher starts with a hypothesis about the data to confirm or disconfirm the underlying factor structure or dimensions. Exploratory factor analysis is undertaken with that hypothesis in mind. For this process, the researcher sees whether there exists association between the initial variables and how they are grouping. Rotation techniques to enhance interpretability. Rotation in factor analysis helps achieve a simpler and more interpretable factor structure. This consists in adjustment of the axis to maximize the distinction between factors, improve the interpretability of the results. Challenge and solution of factor analysis are to ensure the right results. The research has to gather accurately the right set of variables. Keep in mind that besides the knowledge of the product, neglecting even small details might result in wrong results. Factor analysis step. Step number 1, determination of the suitability of data for factor analysis. We have Bartlett's test to check whether the correlation matrix is suitable for factor analysis. We have a Kaiser-Meyer working measure, verified sample adequacy. 0.6 is generally considered acceptable. To choose the extraction method, there are several methods to extract data: principal component analysis, principal axis factoring, common factor analysis, image factoring, maximum likelihood, alpha factoring, unweighted least square, generalized least square, and canonical. Number 3, factors extraction. The extraction method is to be used to identify the initial factors. Starting eigenvalues, you can determine the number of factors to retain. Factors retained in the analysis are typical with eigenvalues greater than 1. Number 4, factor rotation. Rotate the factors using overmax or countermax orthogonal rotation when assuming that the factors are uncorrelated and pro-max, or open rotation to allow the factor to be correlated for a simpler and more interpretable factor structure. Interpret and label the factors. Analyze the results and interpret the underlying meaning of each factor. Assign labels to each factor based on the variables with high loads on that factor. Thank you for watching. Please don't forget to subscribe and like.